Hi there, gang. Welcome back. The next couple of sections are going to deal with applications of the quadratic equation, types of problems that we can look at which are best solved by using the quadratic equation. So we'll just dive in with some examples and you'll begin to see some patterns, I hope. Okay, like with any word problem, which is what we have here, what you need to do is read it enough times so that you get the idea of what's going on. And my advice is read it enough so that you could describe it to somebody who hasn't read it and make sure they understand it. And after you've done that, it's really important to identify what the question is. So the question is usually precedes the question mark. And so the question is, what's the length of the square piece? So that's what we'll assign our variable. We're going to let S equal the length of the square. So now we have a rectangle. And what we have to recognize is what its dimensions are. So it's twice as long as the square piece. So that means for the rectangle, the length is 2S. And it's 3 inches wider, so S plus 3. And those are the dimensions of the rectangle, and that is very important. Now we're told that the area of the rectangle is 108. So area of a rectangle is length times width. So 2S times S plus 3 has to equal 108. So if I multiply that out and simplify it, I get 2S squared plus 6S minus 108 is equal to 0. And if I divide by 2 and factor, I'm going to get S plus 9 times S minus 6 is equal to 0. And so my two solutions to this are minus 9 and 6. And since we're talking about the length of a square, clearly we can't have minus 9. So 6 is my solution. Remember, we always want to answer in a full sentence, and so we'll say the length of the square is 6 inches. Okay, so this was a word problem that gave rise to a quadratic equation. Let's look at one more. So take a few minutes and read this. You can press pause and resume once you've read it and understand what's going on. What I had to do is think about this a little bit, and whenever possible, it's always a good idea to draw a picture. And so the picture should look something like this. Here is my rectangular field. So this length is 120, and this length is 225. And what I'm going to do is create a border. And so that's going to look like this. It certainly doesn't look uniform, but let's assume that it is. And so if we assume that each of these little dimensions is x, then what we get is that this length is 120 minus 2x, and this length is 225 minus 2x. And now we go back and we read this information. The border leaves 65% of the field uncut. So what that means is that this is 65% of the entire field. And so once I have that figured out, then I write the area of this is equal to 65% times the area of that. And here's what we get. Okay, so here's the equation. Check it out. This is the area of the inner part, and it equals 65% of the full rectangle. So it's really messy. Yes, it is, but we've got to multiply it out, simplify, and why don't you press pause and try to do that work and see how simplified you can get it, and then pick up again. So if you did all that multiplication out correctly, I believe this is what you're going to get. And at this point, you can solve it by any technique that you want. And at some point, you should begin thinking about how you solve it using your Inspire. But when you solve it, you get two solutions. You get x is equal to 15, or x is equal to 157.5 feet. Now, there's no way that x could be 157.5 because that would make this negative. So our only possible solution is 15. And so the solution is the width of the cut is 15 feet. All right, so those are the kinds of problems that you get involved with when you're dealing with rectangles. And you'll have some practice with those on your homework, and I hope you find them interesting. All right, that's it for now. Bye-bye.